Hi, I'm Jack, a researcher in Calc Intelligence. I'm going to be talking about the Lambda Editor, which is a research prototype for authoring lambdas in Excel. We built the Lambda Editor to try and understand how users are going to program in spreadsheets and how they might share their code that they write. I'll be going through an example that shows you how to create a function for formatting strings as different titles.
We've got a fresh workbook, so we're going to go ahead and open up the Lambda Editor. Here we have the add-in, which is an interface to the name manager, but it's an interface that is really designed for writing lambdas and also sharing them. So as I said, we're going to be going through the example of taking a string and converting it to different case styles. I won't go through all of the details of this function, but I will cover some key components, and in particular I will cover the component which is taking the string and splitting it into words, because that will let us process each word individually. And for us to do that, we need a text split function, which given a delimiter is going to split the text according to the delimiter, and in this particular instance we want to split it according to a space to get the words. I'm going to develop this in an interactive way using both the grid and the editor. So I'm going to start by creating some inputs to test, and I'll use the same string that we have in the grid. So we're going to put writing some lambdas, and I'm going to call this arg, and we're developing a split function, so I want a delimiter and it's going to be an empty space, and we'll call this delimiter. Now I can sync this into the name manager and it will be available in the grid. The process of implementing this function is really going to come down to taking the characters in the string, finding the positions where the delimiter occurs, and then extracting pieces of string between two delimiters. In order to make this process uniform, we're going to put delimiters at each end of the input string, which means that we always have at least one piece of string that is between two delimiters. So let me add this piece of pre-processing. So I'm going to create an input string, and it's just going to be delimiter, then arg, and then delimiter. Add that, and then we will see that that's the same but with a space at the front and back. Now we need to start processing the input on a character basis, so we'll start by just getting all of the valid positions of characters in the string. So we want to generate an array of numbers, and we can do that using sequence. So we want a sequence from 1 up to the length of string, and I'm going to call this positions. That's the positions. Now we want the individual characters, and so for each position we want to get the character in the string. So that's an iteration over every position, and we can use one of the new array helper functions, which is map. So we're going to map over the positions, and map takes a lambda that takes an individual element of the array and then returns a new element. So we're going to take a position I, and we are going to extract from string character I, and there's only one character. Call this characters. So let's sync this, and now we can test it out in the grid. So we've got positions, that's our list of positions, and then we've got our characters, and you can see that we have the space at the beginning and end. Now we have the characters, we want to find out which character is a delimiter. So this is another map, this time over the characters, and we want to return true or false depending on whether we have a delimiter. So we're going to write a map over the characters. We need our lambda function, and this is going to take a character now, and we're going to compare character to the delimiter, and we're using case sensitive matching. So this gives us an array of booleans where if an element is true it means it's a delimiter. We can test that, and we can see, yep, true for there, and then false, and so on. Now we have that, we want to find the positions where a delimiter begins, because this marks where we start and end collecting text. So this is really just finding the positions where a delimiter exists, and so this is just a filter on positions. So I'm going to filter positions by delimiters, and we will call this start, because this is where we start each new word in the output. We can sync this and then evaluate it, and we can see we've got a delimiter at 1, at 9, 14 and 23, and that means that we want to extract text between 1 and 9, between 9 and 14, and between 14 and 23. So this is another array processing step that we need to do, but it's not a map, because we don't want an element for each one of these. We want an element in between each pair. So we need more control over the array, and for that we're going to use makeArray, another new function. So makeArray takes the dimensions of the output array, and the dimensions are going to be the number of elements in starts minus 1, because we want the in between each delimiter. We're only going to have one column, and then we're going to have a lambda that takes 2 arguments, which is the position in the array we're generating. Because this is just a row with 1 column, we don't care about the column, so we can just make that an underscore. Now we want to extract the start and end positions from our array, so I'm going to use a let just to hold these calculations. So our start is going to be an index into starts at position I, and then our end is going to be the next position on, so I plus 1. And so this is the difference between map and makeArray. With map you are just given the element directly. Here we compute with positions, and so we can access different elements. So now we have the start and end of the delimiters. Now we want to extract the text between that. So it's going to be mid, and it's going to be string, and we want start plus 1 because we don't want to include the delimiter. And then it's end minus start minus 1. That's the number of characters we're extracting. Now let me synchronize that. Oh, I need to give it a name. I'll call this result, because this is the result of the text split. And so now we have the individual words. And if I wanted to modify this, let's try that. Then everything recalculates, and so we kind of see the nice process of developing in the grid and using the editor. Let's fix that up. Of course, this isn't a function, this is just us doing the individual steps. What we really want to do is take these names and then package them up in a lambda, using each one of these name manager names as a let name, and then that way we can reuse it as a function. So one thing I didn't talk about was the editor view, and so this is an alternate representation of the name manager, which is more like a code editor. So if we look here, we can see that here we have a single file that has all of our names that we defined before. Now what we want to do is we want to take these and we want to package it up into a single lambda. And so I've written that one earlier on, and I can copy that in. And so this is our split on lambda, and you can see that here the things that were previously names we've now just made into let definitions. So let me clear these and then synchronize, and now we can call split on a string and a delimiter, and we get our split input. Now this of course isn't the function that's going to capitalize or sort the cases out in our input, so we need a lot more for that. Luckily I've prepared that one earlier, and actually I prepared that in a whole file, and I can just copy that in and create a new namespace. And so that's what I'm going to do. So I'm just going to clear this, and then I'm going to create a new namespace, and I'm going to call this text. and then I will copy in the full definitions that I've written earlier. And then we can synchronize this. And if we look at the manager view, what we see is that each name now has this prefix. And so in the editor view, to make it easier to work with these things, we allow you to split names up by a prefix. And then when they get synced into the name manager, they all have a single hierarchy of names which are prefixed with the namespace. So just to go over these functions quickly, we can see we have this sentence case, which uses our format title function. And this is a lambda that's going to split into words. And then it's going to construct an array by formatting the first word with our head function, formatting the rest of the words with our tail function, and then joining them together. And for sentence case, for the first word, it's proper, so we capitalize the first letter, and everything else is lower. Then for our title case down here, we format it, again, the first word is proper, but then the rest of the words we have this other helper function, getWord. And so this function looks through a dictionary of words, and if it matches, it returns that. Otherwise, it will capitalize it using proper. So now I can test that out in the grid. So I've got text.sentence case, AT, and then I've got text.title case, and that gives me the expected output. We've created our lambdas for formatting strings as titles, and before we use it, we should really test it. So I'm going to go through some small test lambdas, but I'm also going to show how the Lambda editor lets you pull in definitions from GitHub. So you'll see in the top right of the editor, there's my name here, and that's because I'm logged into my GitHub account. And that means that I can use the Lambda Hub, which is a way of bookmarking or favoriting collections of lambdas stored on GitHub. So if I open up the Lambda Hub and I use a subscription, you'll see I have a subscription here for tests, and this points to a gist on GitHub. I can import that, and it's going to create a new namespace for test and insert that into the editor. And if you go to that URL on GitHub, you'll see I have the corresponding definitions there. So what this collection of lambdas does, the most important one is test.cases. It's a lambda. It's going to take a description of the test that we're running. It's going to take your test cases, which is a table of inputs and expected outputs. It takes a test function, that's the thing you're testing, and then it takes a compare function, and this is an optional parameter indicated by the square brackets. By default, if we don't give a compare function, we just use Excel's equality. But if we do provide one, then we use that. So we use these optional parameters and the isOmitted function in order to create a comparison. So we synchronize that, and let's go through an example. So I'm going to write some test cases. So let's do hello world, the fat cat sat on the mat. Here are some test cases. So let's test out our title case function. And so we expect that to look like this. And now we can call our test cases function. So test.cases, we give it a description, title case test. We give it our input output table. We then give it a lambda, which is going to execute on each input output pair. So this is taking a lambda as a value, and we want to test out our title case function. And then lastly, we want to give it a comparison function. So even though this is optional, because we're comparing strings, we want to use case-sensitive matching. So I'm going to create a lambda. It takes 2 parameters, and it's going to run exact on those 2 parameters. Now, my test has failed. It expected the fat count that's sat on the mat in this form to be equal to this, but it's not. It's not that the function is wrong, it's just that my test case actually isn't correct. So let me put this properly into title case. And then last but not least, and so now all of my cases have passed. And we can do a couple of sentence case tests. So let's copy these. And we can run our test cases again, test.cases. And then we want to give it our lambda to evaluate. And then again, we need a special compare function for text. And that also passed all the tests. So that's the Lambda editor. So we have a manager view, which displays the names in the name manager in a prettified way. We have the dual representation of the editor, which has namespaces for organizing names, with the index being the special top level. And then we also have integration with GitHub. So you can have a set of subscriptions so that whenever you open the editor in any different workbook, if you're logged into GitHub, you can pull those in and start using them immediately. And if I want to make changes, I can do that too. So for instance, I might want to put just a comment at the top of this file. I can then re-upload this to GitHub. And now if I look online and refresh, my comment has been added. And so anywhere that I'm using this, I can pull that in.
Next, I'm going to tell you about 3 different research papers that we worked on in our team. First up, I'm going to tell you a bit about uncertain values. This is an aspiration we've had for a long time in Project Yellow, to be able to store an uncertain value in a cell. On the left is how you would do a calculation of compound interest today in Excel, where we're forced to say that in the future we think the APR is going to be exactly 10% in each of the next 4 months. And that's fine, and we'll get a particular answer for the accumulation of the capital over that time. On the right is what we would like to be able to do in Excel, to store uncertain values in cells as inputs and get uncertain values as outputs. So the 4 cells in column E are uncertain predictions, if you like, of what we think the APR might be. We think that it's most likely to be 0.1, but it might be as low as 0 and as high as 0.2, and tailing off as we move away from the midpoint. So that's like 4 uncertain values we put into the cell, and then that propagates. So this calculation of interest over here is uncertain, and so is the final result. So we think the midpoint is 1033, which is the same as what we get out of the deterministic calculation on the left. But the great benefit on the right is we get an indication of what the spread might be, of what the min and the max could be. Now, if we could, now we have this actually running in Excel. So if I bring that up, here we go. There we are. I've got an example. So I've implemented a function, a new function called xsum as a lambda. and it can calculate with uncertain values. So here is someone's budget where their income is 1,000 plus 1,000, and it's calculated there. And these items here are their expenses. And this one here for utilities is actually expressed as a range that Clara, who is building the spreadsheet, is estimating that the utility bill is going to be between 50 and 150. And so that means that when we calculate the expenses, it's coming out as a mean of being 1986. And then when we calculate the balance using XSum, so you see XSum is taking the sum of all these items, including the uncertain values, whoopsie-daisy, we get a mean of 15, and we get a chance, we can calculate using the spread in this uncertain value, we get the chance of whether she is going to be in the black, and it's 3/4. So Clara will think, yeah, that's probably worth taking the chance. But say if the utilities were likely to be a bit higher, maybe instead of between 50 and 150, maybe it was between 50 and 450, then the expenses go up and the balance goes down, and now there's a very slim chance of being above zero. And so using Excel, she can now decide maybe it's not worth taking the risk. I won't buy the sofa. Over on the right, the implementation of XSum is done using the Lambda editor, and it's a few hundred lines. We actually have a parser using recursion to parse these formulas and to evaluate them. And we use Monte Carlo simulations to represent the uncertain values and to get these estimates of the chances of breaking even. So it's really cool that we can now represent uncertain values to some extent anyway using lambdas, and maybe we can have true uncertain values in the grid in the future. We have a research paper about that that's on our website.